Hello students, welcome to lesson 6 on trigonometry. I hope you are all doing well. Good. Now before we begin our lesson, let's take note of the following announcement. After watching this video, if you realize that there was a concept you didn't understand, please call me on my line, okay, for further explanation and clarification. So my phone number is on the flyer on your screen. Pick up the number and give me a call. I also run online private tuition for SHS and NOVDEC students. So if you are in need of these services, or if you know someone who is in need of these services, please give my number to the person for the person to call for enrollment. Right. Thank you. That was just by the way. Now let's begin our lesson. Good. So in our previous lesson, I told you that we'll be looking at trigonometric ratios. Trigonometric ratios. So in our earlier lessons, we talked about the fact that in trigonometry, we are to consider two main relationships. One relationship is between only the length of sides, and the other relationship is between the length of sides and angles. So we have already looked at the relationship between only the length of sides, where we talked about Pythagoras' theorem. So now it's left with the relationship between the length of sides and angles, which is trigonometric ratio. So that is what we are going to do today. We'll be looking at trigonometric ratios. So now, what is a ratio? What is a ratio? So let's look at the definition of a ratio. So a ratio is a relationship between two quantities by division. A ratio is a relationship between two quantities by division. Good. So basically, we need two quantities, and these two quantities should be related by division. So division is basically writing what two numbers in a form of what? A fraction. Okay, where you have a numerator and denominator. Okay, so like A over B is a ratio. It's a division. Okay, good. So the two quantities should be related this way, something over something. Okay, in our case, we were to look at the relationship between the what? The length of sides of the right angle triangle. So we know this side to be what? The hypotenuse. So let's label it H. And depending on the reference angle, if we are using this side as our reference angle, that is theta, this will be what? Our opposite. And then this will be what? Our adjacent. Okay, good. If we are also using this side as our reference angle, then this side will be rather our what? Opposite, and this side will be what? Our adjacent. Okay, so we have to know which angle we are using as what? Our reference angle. Good. So using this one as our reference angle, this side is our opposite, this is hypotenuse, this is what? Adjacent. So the ratio of the length of sides in relation or in reference to this angle is what we call what? Trigonometric ratio. So the ratios of two of what? The length of sides of a right angle triangle in relation to the reference angle is what we call trigonometric ratio. So we can have a relation between the hypotenuse and then the opposite. We can also have a relationship between the hypotenuse and then the adjacent. We can have a relationship between the adjacent and what? Opposite. I hope you get it. In reference to what? This angle. So the relationship between the length of sides and the reference angle is what we call trigonometric ratio. Okay, so now let's determine the ratios we can get from a right angle triangle. So we want to look at the number of ratios we can get from a right angle triangle. So let's look at that. Good. So we have determination of trig ratios. Determination of trig ratios. So we said the two quantities should be related by what? By division. So that is why we have the division sign here. Okay, good. So now let's fill these empty boxes. So the letters that will be filled here will be the numerator of the fraction, and then the letters that will be filled here will be the denominator of the fraction. Okay, so let's quickly fill it up. So I want to choose different colors to represent it. So I'm choosing this one for the opposite, then this one for the adjacent, then this one for the hypotenuse. Good. So let me come here. This will be the hypotenuse. This will be the adjacent, and then this one will be the opposite. Good. Right. So now we are dividing this side, okay, by this side. So we are dividing this side by this side. So letter O divided by letter O. You realize that they are the same thing. So it's what? Cancel out. So we have what? 1. So we put 1 here. Then we have A divided by O. We still have what? A divided by O. So we have A, okay, over O. So O. Then this one we are going to have H. Where is it? We are going to have H divided by O. So we have H over O. Okay, H over O. So H over O. So let's pick our O. I hope you are following. Good. So now let's come to this one. So this one will be O divided by what? A. O divided by A. So let's do that. So O divided by A. So now this side, A divided by A will give us what? 1. So now fill this 4 for me, the last 4. Fill it up for me. And let's see, fill it up, fill it up, fill it up. Quickly, quickly, quickly. Okay, so let's continue. So filling it up, we are going to have this one, O divided by H. So we are going to have O divided by our H, which is this. Okay, then this one will be A divided by what? H. So A divided by H, let's see, let me write this one first. So this one will give us 1, H divided by H. This one is A divided by what? H. So we have H. Okay, then this one we are going to have H divided by A. So H divided by A. Right. So this is our complete table. Okay, we've completed the table. So now you've seen the various ratios we have to have on a right angle or triangle. So now this is 1, 1, 1, 1. So they will not be part of the ratio because they are whole numbers. So 1 is a whole number. So we'll take this one out. Okay, all the 1, we'll take them out. They are not part. Good. So the rest, we have 1, 2, 3, 4, 5, 6. So we have 6 ratios. So the number of trig ratios we can get from a right angle triangle, they are what? 6. So let's look at them. So we have opposite over hypotenuse as 1. We have adjacent over hypotenuse as another. And then finally we have opposite over adjacent as another. Okay. Then we have additional 3. But look at the additional 3 in relation to the first 3. Then you want to look at something. So we have H over A. And then A over O. Good. So these are the 6 trig ratios we have. But we have these 3 as the basic trig ratios. Okay, so these 3 are the basic trig ratios. And these other 3, looking at it, let's see. The opposite here has now become, the opposite here, which is the numerator, has now become what? The denominator. And then the hypotenuse, which is the denominator, has now become what? The numerator. So you realize that, tell me, what can you say about this one and this one? So you realize that this is more or less like the inverse of this, or the reciprocal of what? Of this. When you turn this one upside down, you are going to get this. Okay, so we say that these are the inverse of what? Of these ratios. So these are the basic trig ratios, and these are what? They are inverse. Okay, now in core math we have to look at only the basic trig ratio, the 3 of them, not their what? They are reciprocal in addition. But in elective math you are required to know all the 6 trig ratios. Okay, so in core math we will focus on only these 3 trig ratios. We will not add their reciprocal to it. Good. So now let's look at something. So let me clear this one from there. Now each trig ratio has a unique name. Okay, each trig ratio has a unique name. Now when the opposite is divided by the hypotenuse, we call, or it has the name sine. When the adjacent is divided by the hypotenuse, it is called cosine. And when the opposite is divided by the adjacent, it's called tangent. Okay, tangent. So we have sine, cosine, tangent. These are the names of the trig ratios, the basic trig ratios. So when you divide the opposite by the hypotenuse, you get a trig ratio called what? Sine. When you divide the adjacent by the hypotenuse, you get a trig ratio called what? Cosine. When you divide the opposite by the adjacent, you get a trig ratio called what? Tangent. Okay, so these are the basic trig ratios: sine, cosine, tangent. Okay, good. Now you realize that I told you that these ratios are related to what? The reference angle. So they are in relation to the reference what? Angle. Okay, so if you want to combine the relationship between these ratios and the reference angle, we have a way of what? Writing it. So what we do is that we pick the first 3 letters of the names of the ratios, the first 3 letters. So for sine, we pick the first 3 letters. It is also still bears the name sine. So we write sine. And because we want to relate it to the reference angle, in our case we chose theta as a reference angle, so it's going to be sine theta. So this is when you link the ratio to the what? To the reference angle. So this one will be called what? Cos theta. Okay, and then what will be the name for the last one? Tell me. Good. Tan theta. Tan theta. So we have sine theta, cos theta, tan theta. These are the basic trig ratios. Sine theta, cos theta, tan theta. Okay, so if you want to relate the ratios to the reference angle, this is how you write it. This is how you write it. This is how you write it. Okay, but the ratios themselves, the name is what? Sine, cosine, tangent. I hope you get it. Good. So don't forget this. Sine theta, cos theta, tan theta. If the reference angle is alpha, then it will be sine alpha, cos alpha, tan alpha. I hope you get it. Good. So now that we've determined the trig ratios, let's summarize it all up. Okay, let's summarize it all up. So let's look at the summary of the trig ratios. The summary of the trig ratios. So summary of basic trig ratios. Summary of basic trig ratios. Good. So if this is a right angle triangle, this side being theta, this side being alpha. So we have two angles here, reference angles here. So now if this is opposite, then it means that this was what? Or this is what? Our reference angle. Okay. So the trig ratios in relation to their reference angle that we can get from this right angle triangle are this. So sine theta is opposite over hypotenuse. Cos theta is what? Adjacent over what? Hypotenuse. And then tan theta is what? Opposite over what? Adjacent. So sine theta is opposite over hypotenuse. Cos theta is what? Adjacent over hypotenuse. And then tan theta is what? Opposite over what? Adjacent. I hope you get it. Good. So these ratios are in relation to what? The reference angle theta. Okay. So now, how then do we remember these ratios? So there's a way of remembering the ratios. So what we do is that we link the first letter with the ratio. The first letter with its ratio. The first letter with its ratio. So with sine, we are going to have SOH. Okay. For cosine, we are going to have CAH. CAH. And then for tangent, we are going to have TOA. Okay, so putting the three together, we have SOHCAHTOA. SOHCAHTOA. So remember this, SOHCAHTOA. So means opposite over hypotenuse. Ka means adjacent over hypotenuse. And toa means opposite over what? Adjacent. So SOHCAHTOA. So always remember this. SOHCAHTOA. You can be singing with it. SOHCAHTOA. 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 So means sine is what? Opposite over hypotenuse. Ka means what? Cos is what? Adjacent over hypotenuse. And then toa means what? Tan is what? Opposite over what? Adjacent. So students, this is where we'll bring our lesson to an end. Okay? Good. So we've looked at the trig ratios. Make sure you remember this SOHCAHTOA and make sure you'll be able to write this relation down. Okay? Good. So what I will let you do for me is that with the same right angle triangle, write the trig ratios for alpha as your reference angle. Okay, so that's why this is there. It's not filled. So write the trig ratios using alpha as your reference angle. So till we meet again, revise, read ahead. Bye.